I had two questions. One is from today and one is from about a year ago, and I'd like to answer both questions. First question from Zamzaris. Don't know if you respond much, but could you share how you made that 3D reticle? Been searching everywhere for help, and yours seems perfect. Thank you. So I'm going to show you the reticle that is currently implemented. I haven't worked on this game in quite a while, um, and even the last time I worked on it was after a long hiatus of working on it. But here's where I got on it. I didn't create any enemies yet. There were these towers that kind of shoot these. At the moment, they're really fast guided lasers. You can see it's kind of a mess still. I I had a lot of ideas for it, but just not time to implement it. I was kind of embarrassed about that week that I wanted to do a game in a week, because after that video that I made, stuff came up the entire week and I didn't even get one opportunity to work on the game for the rest of the week, and it just felt really bad to look back on that video and see the kind of the promise of making something and working all week on it, and the falling through of that promise. Anyway, you can see the reticle here. It kind of moves in 3D with the ship's movement, but you can also tell that the reticles themselves look very heads-up displayish. They're actually 2D images being rendered in the HUD, but they're being rendered based on the position of 3D objects that are actually in the scene. So let me show you that and how I set that up. We're going to look at first at the character of the ship. I might refer to it as the R-wing, but it's not an R-wing, obviously. But just for simplicity, I may sometimes call it the R-wing. So here's the ship. Forgive my messiness. I've learned a lot about organization and project management since this project, and so yeah, there's going to be some things that are messy. But here are the two reticle objects. They're just sphere collisions that have, I don't think they have any collision. Yeah, they're set to no collision. They're really just to give me position data. And there's nothing that happens in this blueprint concerning these guys. They're just parented under the R-wing itself. So there's this cube that I didn't name anything. It doesn't really need to be called cube, but it is. And it's this. It just has everything concerning the R-wing and everything underneath the R-wing in it. And this cube is used to move and rotate the R-wing, whereas this R-wing axis right above it is actually to move the camera and the R-wing, the whole scene. The reason I have those two different ones, I'll talk about a bit later when I'm talking about the actual movement component of the scene. But for right now, we'll just kind of focus on these guys. So these two reticles are parented under the cube, along with the R-wing, which I called a Decidi fighter, and a lot of particle systems, just for the engines and for, I think it might just be the engines actually. 6, 7 different engines. I see 8, but whatever. Oh, here. So 8 engines. One is actually named. The rest are just particle system number. Anyway, back on track. These guys are used in the UI reticles widget, which is drawn. I don't remember where I called the draw function for this because I didn't make. I'm looking back at the project today, and I didn't make a HUD blueprint specifically for this project, so I don't know what blueprint is telling this widget to be drawn. I bet you it's actually inside the player controller blueprint, which is a little, I don't know, I guess that might make sense. It's a little sloppy. Anyway, you'll notice I changed the color of the reticles and I rotated them 45 degrees. That's just to distance myself a little bit from the Star Fox franchise for copyright reasons. It doesn't really matter unless I were to actually release and sell this game. But we're going to look at the blueprints for actually positioning these reticles where those 3D objects are in world space. So it's very simple. It looks a little complicated, but it's really simple. There's an initialize event. I believe this only gets called once at the beginning. It probably gets called either by the StarFox character or by the player controller. Okay, I don't even know where this gets called, actually. The initialize reticle event. It doesn't get called in here. Maybe it just doesn't even happen. Maybe this never needs to happen. The only thing that this would do is that when this gets called, it casts the player character of index 0 as a StarFox character. You know, this does need to happen at some point because we need to get the reticle objects from there. So I don't know when this happens, but it does need to happen. But it only needs to happen once so that we can cast. I had a little print string. If it were to fail, it would just tell me the reticle cast failed. This stuff is all connected down here, actually. So the organization is terrible, but simply put, we get the owning player, we project the world to the screen of that player. We get the target reticle objects. These correspond to the objects in this character. So you see the two spheres that are corresponding in front of the R-wing. Those are these reticle 1 and reticle 2. I believe reticle 1 is the closest one, the major one, and reticle 2 is the smaller, farther away one. You can kind of set those up however you want, but the important thing is that their world space, their world location, gets projected from the world to the screen position. And I had to do these math functions in order to get the reticles actually in the right place. I don't remember all of the logic behind why this happens, but I can show you the difference. So if you were to just subtract the regular viewport size from the screen position and not multiply it by 1.5, then when we play, the reticle is up in the top left corner and it moves awkwardly. It just doesn't do what we want it to do. And so I kind of just guess and checked doing some rapid prototyping of math functions to just kind of nudge it into the center of the screen where we want it. And that resulted in dividing the screen by 2, dividing the viewport size by 2 rather. So if we divide the viewport size by 2, we get this. But still, look at how the difference between the big one and the little one are. The big one is the one we're experimenting with right now, and the little one is the one left the way it was in the working game. And you can see how the big one is very sluggish, and it doesn't really look like it's aiming where you're aiming. And I think that's just because the movement is kind of constrained. It's not multiplied to be large enough. So I multiplied the resulting, I guess it's a 2D vector, the resulting 2D vector by 1.5. I tried a bunch of different values, and 1.5 was what I ended up liking. And then the reticle 1 image is translated by that amount. Same thing happens with reticle 2. So we get the object, get the world location, project world to screen of player 1, or of owning player of this blueprint. Screen position minus viewport size divided by 2, that's important. And then multiplied by 1.5, set the translation of that image. And these happen every tick. So every tick of the game, we're updating that, and I guess that's the only way I can think of to do it. I think it has to happen every tick, and then you get something like this. The problem with this is it's not quite precise. You'll notice if I'm aiming, I mean, it's enough for the player to get kind of a good idea of where they're shooting, but if I turn really sharp, the lasers are not shooting where the reticle is aiming. See what I mean? And you can call that leading or something, but ultimately, in reality, it's just I eyeballed it. So it's not perfect. You would have to do a lot more calculation and compensation in blueprints to make sure the lasers are aiming to hit something that's in the reticle if you were going to do that. But I think this was good enough that it feels pretty good to play. That being said, I don't have a lot of moving enemies. In fact, I don't think I have any moving enemies in this demo, so that could change the paradigm of it a little bit. Maybe it would not work the way it is, and maybe I'd have to solve that problem. But I hope that at least helps to understand how the reticles are being rendered and being placed in a 3D space, even though they're 2D elements in the HUD. We're going to get on to the second question by Reisterstuffs. From 1 year ago. I'm sorry I did not answer this question for a whole year. I would like to get better at answering questions and collaborating and all that, and this is a step in that direction. Better late than never. Sorry for not answering it sooner. So we're going to answer the question, how did you manage to make those controls? I've been trying to do that for ages. And this is a little more complex than the reticles. The controls, they're not really complex, but I added a lot of my own little finesse to them, and so it's gonna be a little bit of a walkthrough. So the roll, what I'm doing currently is that the roll of the ship is controlled by the right thumbstick, and the way I'm going to try and visualize it for you right now. The way I was doing the roll is basically, if your right thumbstick is like a clock face, whatever time you're aiming at is the up vector of the ship. So you can kind of roll fast and do really controlled rolls. It feels really good. I don't know if it's necessary, except to stylishly dodge things. Also, you get the snapping. If you roll too fast, it'll snap a little bit, which is not fun. But that's how the roll happens. The actual aiming is obviously with the left thumbstick, and currently I bound the firing button to the right bumper of the controller. Doesn't really matter, but that's what it is right now, just for your kind of, so you can comprehend the blueprints a little easier. So this is just controlling the roll. We're getting the roll Y and the roll X. I believe these are just telling us the roll Y is the value up and down of the right thumbstick. The roll X is the left and right value of the thumbstick. I did a -1 here because it's just basically inverting that control. I think the usual +1 roll Y is down, and so I'm multiplying it so that it's up. I believe that's true. This is kind of an old project, so I'm not fully sure about that, but it was just to calibrate for me that roll. We make a vector x, y, and z is 0. We make a rotation from that vector and break that rotator into a roll, and that roll enters into this big mess, which just dictates it dictates the roll. All of this is created so that we can float interpolate from our current roll to the new roll. It just kind of smooths out that roll a little bit. The reason I have these quadrants, so this, I believe C roll, see, that's the problem with diving into such an old project. I believe C roll is the current roll. I think C stands for current. Current roll, it's every tick we branch for control enabled. And that's just so that I can disable it for cutscenes and things if I want to. If that branch is true, we set current roll speed to 0. We set current turn X to the movement yaw. But we interpolate it. So we take the current turn X, we interpolate it to the current move yaw. And that becomes the current turn X, the new current turn X that's used to actually turn the ship. Same thing with the Y. So if I don't know if there's a better way to demonstrate this, but the current turn X is basically nothing until we have input from the controller. This is the controller telling us the X value of the left thumbstick, and if the left thumbstick changes, we interpolate the current X value toward that, so that we get kind of a smooth turn. Same thing with the Y happens up here. I don't know why new pitch is a variable and not an input. I'm guessing new pitch. Let's see. Does new pitch happen somewhere else? I might search for it really quick. New pitch. Find references. Set new pitch. Oh, up here. Okay. So the pitch seems to be a little different than the yaw, in that it looks like it's just whether it's inverted or not. That's funny. I guess that makes sense. So the new pitch is set whenever the movement pitch changes, and based on whether it's inverted or not, it becomes positive or negative. Cool. So that's all that is. Then the new pitch gets targeted by the current turn Y and interpolated towards. And so that's how we get our turn X and turn Y. We get our current roll from the interpolation here. This is minimizing that jitteriness from the roll. it's trying to take the current roll and see whether it's, you know, whether this is greater than 0 or whether our new input is greater than 0 in terms of that clock face. And it's trying to see if it's greater than 90 or less than negative 90. And these all basically, so if it's greater than 90, we go with negative 360 for this selection. If not, we go with positive 360. Then we add the current roll to that. And it's basically in an effort to create one seamless roll, since we're interpolating. It's quite a workaround. So basically, I think it's taking any value that goes negative by too much and swapping it up so that it's within a certain range. And then we either select the value that we've created or not based on whether it's greater than 0 or whether this is greater than 0. It's kind of complicated to talk about. It's kind of complicated to figure out, and it's also not. I don't think it's the main reason the question was asked. But I hope I've at least somewhat helped to understand this section, the roll section, and we interpolate to that new angle. I may demonstrate afterwards the difference between having these on and having them not on. In fact, you know what? I'll just do it right now. So instead of saying all of this, what I'll just do is set the current roll to current and show you what it does. So if we're just doing that roll without any calculations, we always get this step effect, and you can't do a whole barrel roll. See what I'm saying? So as soon as you get past that 180-degree mark, it flips the whole thing. The whole ship gets flipped because you're just nudging it right past that 180-degree point. And so what I did was, in here, these are basically built to fix that problem. So we now have this as the current roll, this sum of our conditions. And so you can roll and get a nice smooth barrel roll if you want to. It feels pretty nice. You just can't go too fast, or you get that snagging. But that would be a problem for another time. I'm going to move on to movement, which is it's done 100% through add relative location nodes, and those are all based on these. I believe maybe there aren't interpolations here. Never mind. I was thinking there were. So we interpolate these. I believe are to actually rotate the ship, and this is all just to move it. So if we take a look at this sequence of events, you take the c turn x, you take the c turn y, multiply them by the aim speed, which I've just made 45 degrees in this instance. You really just kind of eyeball it. And then out of that you make a rotator, which has your current roll as the roll, and then your pitch as the pitch, your yaw as the yaw. Rather, your c turn x as the yaw and c turn y as the pitch. C turn being current turn. The cube, which I should have named something else, but this is just basically controlling everything that's under the R wing that's not under that doesn't involve the camera. Everything that doesn't involve the camera gets set, rotated here. And then we go to a sequence, and this sequence branches quite a few times. So let's take a look at this. You take your strafe speed, which I set to 13. This strafe speed is just dictating how fast the ship moves around the screen. This really also only dictates the ship moving 2 dimensions in the screen space. I'll talk to you about the on-rails section afterwards. So we take the strafe speed, we multiply it by the current turn x and current turn y. This being x down here and y being up here, I believe. And then it looks like we're checking whether these are greater than 0 and whether they're less than or equal to negative or positive and negative 540. Oh, greater than or equal to here, less than or equal to here. And as long as none of these are true, we add the location. If they are true, it looks like sorry, let me look through this really quick. So this is looking at greater than or equal to 320, less than or equal to negative 310. I think this is just the screen space. Like these numbers are literally talking about going between the y value in the screen space, sorry, the z value in physical space, but the screen space y value, 320 and 0. And basically, if we're checking the 2 boundaries, so if this multiplied by the strafe speed is greater than 0, and so it's a NOR, right? So that means it means neither of these can be true. Sorry, I'm walking through this project that's such an old project. The important thing is we're taking the cube's relative location in space relative to the blueprint itself. We're breaking that vector into the y and z values. I guess the cube's y value, I don't really know why we're doing y and z. I would think it would be x and z. Let's look at the cube really quick just to check. Oh, okay, so the x is pointing forward. That's why we're doing the z for vertical and the y for horizontal. That's really confusing, but it makes sense in this case. Just because y is there, z is there, y is horizontal, z is vertical. Only in this relative location sense. So we're looking at the y horizontal values here and the z vertical values here. And we're basically just using these to check that the ship is inside those boundaries so that it doesn't go beyond our camera bounds. And these branches, like each one of these branches is for one boundary. So I believe this is maybe the top of the screen, this is maybe the bottom of the screen, this is maybe the left and right boundaries of the screen. And so basically, if your ship is within these boundaries, then you can get these location changes. If it hits these boundaries at all, then you cannot make these location changes. So why are there two? Here's the thing. What I mean is, why are there two for each? And you'll see the second set of add locations is for the R-wing axis. So this is a very subtle thing. The first two here are setting the location, or they're adding the location to the cube, which is adding transforms to this whole set of things, right? But not to the camera. Everything parented or having to do with the R-wing moves here, but not the camera. These second two are moving the camera and the R-wing. So if we select the R-wing axis here, you'll see everything is moving. The camera, the R-wing, the reticles, all of that. They're moving inside the player blueprint, still relative, but the camera's involved this time. And you'll see that very subtly here. So when we go to the right, the camera moves a little bit to the right. When we go to the left, the camera moves a little bit to the left. You can kind of tell if you look at the asteroids. See how they're kind of moving based on our control? The whole background is moving based on our controller. And that's because the R-wing axis is moving very slowly, and the R-wing itself is moving more than that underneath it. It's so subtle you might not even see it really, but it feels really nice. It feels way better than just moving the R-wing around on the screen. So the other portion of this is the on-rails portion, where we actually move forward. That was done using these level sequences. And the sequencer gets implemented, I believe, in the level blueprint. So if we take a look here, this is the level blueprint. Oh, here's where the UI reticles get created. That makes sense too, I guess. I would probably put this in the HUD nowadays, in the HUD blueprint instead of the level blueprint, but whatever. So that's very simple. You get the player controller 0, add the UI reticles. Oh, that's where you call the initialize reticle as well. So you initialize the reticle here, right at the beginning of play. That initialize is just to cast to the player so that you can get those reticle positions. I had these console commands that I put in. They're really just to improve the shadows at a distance, because there are some big distances in this map, and I'm a sucker for really nice shadows. This isn't really necessary, I don't think, anymore. I don't know, maybe it is. But it's just a series of console commands for shadows. Then we create the level sequences. So one is just for the R-wing, the other one is just for everything else. The reason for that was because I wanted you to be able to boost or break, which would speed up or slow down the sequence that plays for your R-wing, and not have that affect the sequence playing for everything else. So if these were together, the background and the R-wing sequences, and you put on the brakes, everything in the scene would slow down. It would look like you're going in slow motion. But if you just have a sequence just for the R-wing, you slow that down, then it'll slow down just for your R-wing. I have a playback range set at 70 frames. This is just skipping that intro sequence, and it plays. Same thing happens with the background. I'll show you the background sequence really quick. It's not special, but just so you kind of get the idea of what's going on in the background. I think it's actually just these few. I was going to add more rotation to other stuff later, but you know, very, very simple, very slow, very simple. but necessary, important. So it's important to have those two sequences separate from each other for breaking and boosting purposes, even though I never implemented the breaking and boosting system. And I think that about does it. If I wasn't clear enough about anything, I'm sorry. You can let me know. I'll try to do a better job next time. And I'll try to edit this down to be a little more concise so I'm not rambling too much. But I hope that helps. I feel really bad for making one video where I start to make a game in a week and then I don't. Hey, there's an R-wing. What's he doing up there? Yeah, I hate looking back on videos like that where I say something really ambitious that I want to do and then obviously I didn't. But that's just the way things go. Thanks for watching. Sorry I was so late on that question.